In this video, we're going to look at how to solve standard one-step, two-step equations with variables now on both sides of the equal sign. So what I mean by that is I have a b here on the left and on the right. What I need to do is get everything that has that variable on the one side, everything that does not have that variable on the other side. So I can either move the 13b to the left or the 1b, or the 13b from left to right and the 1b from right to left, one way or the other. I'm going to choose to move this b from the right to the left. That way I'm subtracting 1b and I'm going to get 12b over here. Or if I had done the other way, I would have gotten b minus 13b, which would give me a negative number. Just makes a little bit extra work for me. So what I get here when I do that, 12b equals 27. And now I'm just solving my standard one-step equations. Divide by 12 and b will equal 27 over 12, which reduces to b, if I divide both of these by 3, 9 over 4. Okay, in this one, same thing. I can either subtract 6n from both sides, because I have an n on both sides, or I can add 2n to both sides. I'm going to choose to do that because that's going to give me a positive value of n, and positive 8n over here. Those canceled out. Make sure you keep your plus 21 coming down. Equals, I didn't change that negative 3, so it stays. And then we said the two n's canceled each other out. From here, I'm solving just like I did in the last video. So I have 8n plus 21. I need to get rid of the plus 21 by subtracting it from both sides, leaving me 8n equals negative 24. Divide both sides by 8 to give me n equals negative 3. Okay, here's a couple more that add into it some of the concepts we did in the last one. What I'm going to have to do first is try to simplify. I have a negative 5 here that's going to have to get distributed into this equation. So 4d didn't change, but when I multiply negative 5 by d, I will get negative 5d. And when I multiply negative 5 by negative 1, I'll get positive 5. Now I'm going to keep the right-hand side the same for now. From here, let's combine like terms. We should always try to combine like terms on one side of the equation or the other. What I'm going to see here is that I have on the right-hand side a 3 and a 2. Well, that can just become 5 minus d. And on this side, I have a 4d and a negative 5d. That'll become a negative d plus 5. Okay, you may notice something already, but let's just kind of continue through here and see what's going on here. I said I need to get the d's all on one side, so I'll get rid of this negative d by adding a d to both sides. That gets rid of this, but negative d and positive d just cancel each other out. All I have left is 5 equals 5. Well, that is obviously a true statement. 5 and 5 are the same thing. Anytime you get something that says true, it's a true statement. This is infinite solutions. That means that no matter what I plug in for the variable d, I'm going to get I'm always going to get a valid answer no matter what I plug in. Sometimes they see I'm using this sideways 8 infinity mark. That can be done as well. You need to just say infinite solutions, infinity, as your answers. Okay, let's do the same idea over on this one. Combine like terms with these guys. I'll get negative 2q because I have positive 3 and negative 5. I still have this plus 6 I didn't touch, so I'll keep it as is. On this side, I have a negative 2q. And by combining like terms, I get positive 9 on the right-hand side. Again, I want to go and try to combine my like terms. So I'm going to add 2q to both sides. Going to make those cancel out. And look, again, we have negative 2q and positive 2q. They're going to cancel each other out yet again. So I'm left with 6 is equal to 9, which definitely is not true. This is a false statement. Anytime I get a false statement like that, this means that there are no solutions. No matter what I plug in for q, no matter what value I plug in, I will not get a possible answer that makes that equation true. Sometimes we put a little line, 0 with a line through it for does not exist. Sometimes we actually say does not exist, no solutions. Any one of those is proper. As long as you say no solutions, infinite solutions, does not exist, whatever way you choose.